The temporal index maintains a tree structure, where each node represents a time window of configurable granularity. Window boundaries are established at initialization and remain fixed throughout the index lifecycle. Nodes store references to records, whose timestamps fall within their designated ranges. The consolidation mechanism operates on idle indexes to merge adjacent windows whose combined occupancy falls below a configurable threshold, reducing pointer, overhead, and improving cache locality during traversal operations. Window consolidation is triggered when the index enters an idle state, defined as the absence of write operations for a duration exceeding the idle threshold parameter, specified in milliseconds with a default value of 5,000. The consolidation process evaluates each parent node and its immediate children, calculating the total record count across all children. If this count remains below the merge cardinality limit, typically set to 512 records, the children are consolidated into their parent, and child pointers are invalidated. The operation is atomic with respect to concurrent read operations. Traversal optimization occurs during query execution, when the index evaluates a temporal predicate. The traversal algorithm begins at the root and recursively visits child nodes whose time ranges intersect the query window. Pruning eliminates branches where all records have been marked as deleted or archived. The traversal maintains a depth counter and applies early termination when the depth exceeds max traversal depth, returning results accumulated to that point rather than continuing further. This prevents pathological behavior on extremely deep indexes. The window span configuration parameter defines the time duration represented by each leaf node in the index. Typical values range from 1 millisecond to 1 hour depending on the application workload. Smaller spans increase tree depth and memory overhead, but improve query precision for narrow temporal ranges. Larger spans reduce tree depth at the cost of scanning more unrelated records during queries. The optimal span is determined empirically through measurement of query selectivity and tree traversal cost on representative workloads. Record retention policies interact with the consolidation mechanism. When a retention policy causes records to be archived, the corresponding leaf nodes are marked with an archive flag. During consolidation, nodes containing only archived records are not candidates for merging with non-archived siblings. This preserves the ability to locate and retrieve archived data through separate index paths. The archive flag is cleared when new records within a node's time window are inserted, causing the node to transition back to active status. The branch factor parameter controls the maximum number of children each internal node may contain before splitting occurs. A branch factor of 8 is typical and represents a reasonable trade-off between tree depth and node size. When a node reaches its branch factor limit during record insertion, it splits into 2 nodes, and a new parent is created if necessary. The split operation is performed inline during insertion without requiring a separate rebalancing phase, keeping insertion latency predictable. Pruning decisions during traversal depend on node metadata that tracks the minimum and maximum timestamps within each subtree. These bounds are computed during insertion and updated when consolidation occurs. A child node is pruned if its maximum timestamp precedes the query window's start time, or its minimum timestamp exceeds the query window's end time. Tight timestamp bounds reduce false positive traversals, particularly for queries on recent data in append-heavy workloads. Bounds are maintained as 64-bit unsigned integers representing milliseconds since epoch. The consolidation algorithm evaluates candidates in breadth-first order starting from the shallowest depth. This prevents scenarios where a parent node consolidation makes child consolidation invalid or redundant. Each candidate evaluation checks the total record count and the cumulative deletion percentage. If more than consolidation deletion threshold % of records in the candidate subtree are marked deleted, the subtree is skipped to avoid merging recently deleted regions. The threshold defaults to 30%. Memory overhead is estimated by counting the number of active nodes in the index tree. Each node requires a fixed memory allocation of approximately 256 bytes for metadata, plus 8 bytes per child pointer and 16 bytes per record reference. The consolidation mechanism is automatically triggered when memory usage exceeds the soft memory limit parameter. If memory continues to grow beyond the hard memory limit, new record insertions are blocked until consolidation completes and frees sufficient memory. Both limits are specified in megabytes. Concurrent read operations are protected from consolidation through a read-write lock acquired at the root level. When consolidation begins, a write lock is held only for the brief duration of pointer updates. Reads proceed through a shared lock that does not block consolidation. If a read operation traverses a branch being consolidated, it completes using the pre-consolidation structure. Subsequent reads observe the consolidated structure. This design ensures that no read operation is ever blocked for extended periods by consolidation activity. Range queries benefit significantly from optimized branch pruning because they typically intersect multiple leaf nodes. The query processor estimates the number of nodes to visit based on query bounds and the configured window span. If the estimated node count exceeds a threshold, the processor switches to an alternative strategy. It retrieves all records and filters them in memory rather than traversing the index. This threshold is configurable via the range query threshold parameter and typically set to 256 nodes. The index maintains statistics about traversal patterns to inform consolidation decisions. After every 10,000 queries, the index computes the average branch factor of visited nodes and the percentage of pruned branches. If pruned branches consistently exceed 60%, the consolidation threshold is lowered to increase the merge rate. If traversal depth exceeds predicted depth for the current record count, the system considers whether the window span should be increased to reduce tree height. Deletion operations mark records as deleted rather than removing them immediately. Deleted records continue to occupy space and traversal cost until consolidation occurs. The deletion batch threshold parameter specifies the number of accumulated deletions before the index is marked as a consolidation candidate. Once this threshold is reached, the next idle period triggers consolidation that physically removes deleted records from the affected leaf nodes. The default threshold is 1,000 deletions. The index supports bulk insert operations through a specialized batch consolidation mode. When records are inserted in temporal order in batches of 10,000 or more, the index temporarily disables the branch factor limit and allows nodes to grow to accommodate all records. After the batch completes, the index retroactively applies the branch factor constraint through a rebalancing pass. This approach amortizes rebalancing cost and achieves higher throughput for bulk loads than incremental insertion. Query performance is measured through a latency histogram that tracks the distribution of traversal times across all queries. The histogram is divided into 20 buckets covering the range from 1 microsecond to 1 second. If queries in the 95th percentile exceed a configured target query latency, diagnostic information is logged identifying the deepest traversed path and the number of pruned branches. This information guides tuning of window span and branch factor parameters for the specific query workload. The temporal index is persisted to disk through serialization of the entire tree structure, written sequentially to minimize seek time. When the index is reloaded, it is reconstructed in memory from the serialized form. The serialization format includes a header containing the configured parameters and the current tree structure. A checksum validates the serialized data integrity. Upon startup, if the checksum fails, the index is discarded and rebuilt from record timestamps, an operation that requires a full table scan.